Personal finance practice problem using OneNote. Rate of increase. Let's talk finance, and this time it's personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side, the Practice Problems tab, down in the 1123 Rate of Increase tab. Also note, when using OneNote, look at the Immersive Reader tool. Our presentations will also be in the text area with the same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got our information up top, calculations on down below. We're looking at a rate of increase, which is a kind of ratio type of analysis. Ratios being something that are often intimidating to many people, but something that are crucial both for the measurement of the personal finance as well as any kind of performance type of activity. So it will be applicable in things like job performance oftentimes, which we can see if we look at job performance of highly visible people such as athletes, where we have to use ratio analysis all the time if we're trying to measure performance. So these things are something, the basic ratio analysis is just really a division problem. So what really is difficult about it most of the time is for people to kind of interpret the results when they start to use the ratios. And it's also intimidating due to the fact that whenever we think about ratios and this kind of statistics, no one statistic is difficult really to calculate, but people can use one statistic to basically give a false impression, just as they could with like one piece of truth when you're thinking in terms of language. In other words, if someone is going to lie to you, they will typically give you one small piece of truth and then pile on a whole bunch of lies on top of that one piece of truth. And when we hear that verbally, we often are able to pick that up intuitively because we practice that all the time and say, hey, look, you said one true thing and everything else you said was lies. But when you do it statistically, it can be a little bit difficult to basically pick that up as easily. And that's why I think people get to a negative impression about statistics in and of themselves, thinking that statistics are useless given the fact that people misuse them. And instead, you gotta basically get a better understanding of the statistics so that you can see when people are misusing them in the same way that you would when you're interpreting someone with language on how they may misuse language to manipulate and deceive. So let's get to our basic calculation here. We have the purchase of a truck. The cost is starting off at the $18,000. We're going to assume that 5 years are going to be passing, and we're going to assume that the current price of the similar truck is $22,000. So we're not assuming here that we have the same truck that went up in value. That's not likely to happen. It's the truck as we use it will most likely decline or depreciate in value. What we are assuming instead is that if we purchased a similar truck 5 years later, the cost of that truck would be higher than what we paid for it 5 years ago. One indication or one reason that might be is due to inflation, time value of money, meaning that the purchasing power of the dollar has gone down. Now, this is a really important concept when you do financial planning, especially if you're doing financial planning on the long term, because that inflation over a long period of time will have a significant impact, even if you're in a period of moderate inflation. And realize that if you're looking over a lifetime or over like a 30-year period of savings or something like that, you are bound to have some periods that will have larger inflation standpoints where the costs are going up more rapidly, and bound to have some periods where they're going to be less so. And oftentimes when we're stuck in one period or another, meaning if you happen to be in a very long cycle of low interest rates and low inflation, it's hard to imagine interest rates going up. And if you're in a period of high interest rates and inflation, like in the US around the 70s was a lot higher than in 2010, 2020 or something like that, then it could be hard to think about inflation being under control and going back down. So you want to make sure that you get this kind of idea and concept. Now note that we're applying this to one thing here, an actual truck, a fairly large piece. If you were to measure something like inflation to something else like food or gas or something like that that has a separate or a different dollar amount, then we couldn't really compare. We couldn't use a comparison with dollar amount changes, but we could use a percentage change to try to say, well, is there an equivalent increase happening to other things like gas and whatnot? This is kind of what they do when you hear about people talking about inflation in terms of finance and news, although realize that when they're talking about inflations, they're often kind of adjusting the number to try to see if the inflation is short-term or long-term, and that could have consequences on their calculations as well. So that's going to be our baseline, and then we're going to do some comparisons and assume that the actual change from the truck in years 2, 3, and 4, and 5 were down here, and then we'll do some more comparisons to the base year as well to a year-by-year incremental increase. So first, let's just think about the rate of increase. What we would do is we'd say the current price is $22,000. We're going to compare that to the cost of the truck in the past, which is $18,000. The difference between the two is going to be $4,000. So we have a $4,000 difference over the 5-year time period. Again, that can be useful knowledge for us to know with regards to trucks. And if we were to compare other trucks that cost the same amount, then that can be useful for us to know. But we might then want to say, well, can I take that 4,000 change and say, are other things going up in an equivalent fashion, such as milk and whatnot, food, groceries, and that kind of stuff, gasoline? You couldn't really compare the 4,000 to other things in that way in a similar fashion as you couldn't really compare if you're trying to measure performance of like an instructor and you're trying to determine how many people are showing up to the class. You can't really say, well, if there's 5 people that didn't show up to this class and compare that to 5 people that didn't show up in another class, and one class only has 30 students in it while the other class has 100 students in it, then you know it wouldn't be a fair comparison between the two. What you would have to do when measuring performance would then be to use some kind of statistical analysis. The other kind of comparison similar to this would be job performance, like a baseball player. When you're trying to see how many times someone got on base, for example, then you'd have to take a look at how many at-bats they had in order to have an attempt to get onto base. Otherwise, again, it would be an unfair comparison comparing someone who has more at-bats than someone that has fewer at-bats to see how many times, you know, they got on base or struck out and that kind of thing. So we have to then do this ratio analysis. So we're then going to be saying, all right, let's compare the 4,000. We're going to compare that to the base year, not to the second number, but to the base number. So we're going to take the 4,000 divided by the 18,000. That'll give us our 0.2222. Moving the decimal 2 places over gives us the 22.22%. So that was over a 5-year period, note. So we might say, well, let's break this down by a year-by-year basis and see what happens on a year-by-year calculation. So here's the year-by-year numbers. We're gonna build our table. Highly useful to build the table in Excel. We do work this problem in Excel. So if you want to work it there, you can, to try to kind of build these tables out. It's useful to do it by hand too, but doing it in Excel is really good practice for actual practice. And then we're going to say that we have our numbers here, which are the amounts. Base year is at the 18,000. Then we've got the 18,750. Then it went up to 19,350. Then to 19,900, and finally to the 22,000. Note, it is possible for the truck to decline in value, for it to go down. That's usually if all the stuff in the economy goes down, we'd have a period of deflation, prices going down, which is usually a dangerous thing, and that's something that the government tries to avoid from happening. But an individual product could go down in price, and that could have to do with something like the inputs being different. For example, labor costs might go down for whatever reason, or some of the inputs within the car, the metals and whatnot, may be cheaper for whatever reason, which could result in an individual product declining over time. But often, again, due to inflation, the value of the dollar, the cost of things generally goes up. So then we're going to say, okay, let's see the change. Now, obviously, if we look at the change between the first year we're starting at, there's no change there. We're then going to say that we have the new year, year 2, compare it to the base year. So we're then going to be taking our trusty calculator. We'll take the new year's 18750, it went up, minus the 18000, went up by 750. And then we can take the percentage change, comparing it to the prior year. So it went up compared to the prior year, dividing the change by the prior year, 18,000. That's going to give us, if we move the decimal 2 places over, about 4.17%. And then we're going to say in year 3, it went up to 19,350. So I'm going to take the 19,350 minus the prior year, 18,750. We have a change of $600. I'm going to take that $600 and compare it to the prior year to get our percent increase. divided by the 18,750. That's going to give us about, if we move the decimal place over, 3.2%. And then we're going to say it went up to 19.9. So if I take the 19.9, 199.00 minus the prior year of 19,350, we've got a difference or change of 550. I'm going to compare that by dividing by the prior year, the 19,350, and moving the decimal 2 places over, we've got a 2.84 change. And then finally, in year 5, we're going to say that we have the change that went up more substantially here of the 22,000 minus the 19,900. That's going to give us a 2,100 change. Taking that divided by the prior year of the 19,900, that's going to give us then, moving the decimal over, a 10.55% change. So now we can kind of see these changes on a year-by-year basis. We can say, okay, it's been going up from the prior year by these dollar amounts, but once again, the percent might be easier to see. And if we were to compare the truck compared to something else of a different dollar amount, like gas prices or something like that, or food or milk, then the percent changes are something that we can compare, whereas we can't really obviously compare the dollar amount changes. That's the point. And that, again, is applicable for basically anything that we're trying to measure. If you're trying to compare one thing to another thing, you almost always have to end up using the ratio analysis to some degree to make it a fair comparison. And to make it a fair comparison, you need to understand what the ratios mean so that you can interpret them. So then down here, we're going to say, of course, now we've got this big increase of the 10.55 increase, which tells us a little bit more about the detail of what happened from years 1 to 5. Or in other words, if I was to take our prior calculation, the 22,000 minus the 18,000 over the 5-year time period, we had a $4,000 change, you'll recall, divided by the 18,000. So over the 5 years, we had about 22.22% that we calculated up top. And then we could see basically the detail of what happened on basically a year-by-year basis. Now, the next way you might see this happen is we might choose a base year, such as this first year, and then try to compare each of the following years to the base year so that we have a comparison that's always going back to the base instead of having our base year increase each time. Also a very common kind of comparison when we're trying to see what's happening over time. So we'll use the same data. We've got years 1 through 5. We've got the 18,000 to the 22,000 in terms of our years that the price of the car. If we take year 1, then compare year 1 to year 1. Obviously, there's no change in year 1, and there's no percentage change in year 1. If we take then year 2, it went up to 18,750. So once again, we've got our comparison to the 18. So the 18,750 minus the base year of 18,000 is going to give us our 750 change. And now this is a common way that you'll see the tables. We want to take the changed column, divide it by the prior year or base year, which is the 18,000. Taking that divided by the 18,000, that's going to give us, if I move the decimal place over, that 4.17. Now here's where things change, because the next time it went up to 19,350. We're not going to compare that to the prior year of the 18,750, but rather to the base year of the 18,000. So we have the same base that we're working with. So now we got the 19,350 minus the 18,000. That gives us our 1,350. Taking that divided by the base year, 18,000, is going to give us our 7.5 or 0.075 or 7.5%. And then we're going to say we got now the 19.9, and we're going to compare that once again not to the prior year, 19,350, but rather to the base year of the 18,000. So now if you got the 19.9 minus the 18,000, that gives us our 1,900 change, taking the change divided by the base year, divided by the 18,000. And that's going to give us, if we move the decimal 2 places over, 10.56%. And then finally, we've got the 22,000. At the last year, we're going to compare that not to the prior year, the 19.9, but rather to the base year of the 18,000, taking the 22,000 minus the 18,000. And that's going to give us our 4,000 change. Notice this is just the first calculation we had. And then we're going to take that divided by the base year, 18,000. And that's going to give us our 22% that we saw before, 22.22%. So now we can once again see the changes that are taking place as we compare it to the base year, which can give us a different kind of look at this. And remember, when you're using statistical analysis, if I'm trying to figure, for example, one hitter versus another hitter, or especially if I'm comparing things that are complex, of like one hitter that was in a different era than another hitter, or one job, because it's just basically job performance. When you're looking at athletes, we're trying to measure their job performance to say who's the best and whatnot. So that's the same thing you would do in anybody's job performance, right? You're going to take whatever statistical measures you can to try to measure their performance in a way that's fair, which isn't just subjective, like I like this person, so I'm going to be, right? You're trying to put the numbers down so that you can eliminate your bias by basically making some concrete thing that we can do. And so what we do when we do that is we want to then look at it from as many angles as possible. So notice that just this set of data, the change and the percentages, will give us another look than these changes here, right? That are compared to the base year and the percent changes. And we can look at the trends that are taking place in both of them and then possibly compare them to some other set of goods and whatnot and see if we have a similar change, and then see if we can come up with a story that makes sense, that fits the world about what is actually happening, to make predictions about our finances and how we should be putting them together in the future.